So, good afternoon, everyone. So, this is my video presentation of my project, of our project, and automata theory course. This is so the project I've chosen is Project 8, which is namely the interactive RedX parser, for example. So, I will demonstrate on how to use our application itself. So, so this is a way to run our program. So I've stated here. So Python and the file name will run it to the terminal. So here I have put in an instruction here so that it would easily have guide to how to use our program and what operands and operators to use and what operands to place like somewhat like that. Like it accept alphanumeric like letters and the digits. So for the operands, like for example, if you input like ABC, like ABDD, like you use the plus operand, it is not it is not recognized by my program. So it will provide an error. It somewhat catches that error. So somewhat catches that error because plus is not recognized by my program. So you need to input as instead of plus, you need to use this or operator, or, or in this case, it's union. So, like for example, we will test something that is recognized by my program. So here we'll test the test cases in our research paper so that it's much formal. So let's test simply the simple concatenation. Let's input AB regex. So here when you input it automatically when you just input this, you will automatically receive all the transition table, the summary of NFA, and as well as the DFA itself, and the accepting states, and yes, something like that. All the requirements of the project itself. This so again, this is your input, AB, infix, regex, and the postfix is the function that is commonly used so that the program or the computer itself can recognize what to concatenate, or what to do with the operands and the operators itself, or what is the sequence kumbaga. So that's what the postfix do. And the summary, like the summary of how states works, like this my kumbaga this my in this case I use S and instead of Q when we lesson because I don't know. So this is just a simple diagram, but I in this case I have option if you could generate a PNG diagram or like a visualizer because I found library in Python which is this graphics visualizer, like show simple diagram of like of these states kumbaga. So I'll show you that later. So first I'm going to let's say we'll input tests or test strings on FNA. NFA. So here here it is. We'll input, like for example we use AB, right? So AB. So here we input AB, so we will test it like input AB. So AB. So yes, it is accepted. For example, if we input A, it will be rejected because the pattern it should be AB or the concatenation or simple combination of AB. So that's the only red X, or that's the only pattern it recognized. So let's say C, no, like B, no, like the AB is the kumbaga, that's the combination itself, the red X. So that's that. So let's go back. Let's try another test case, like from the union part, simple union. So we will go back and enter, like say, and let this, we'll choose this, enter a new. Let's say, let's try the DFA. In the DFA, so it's similar to the NFA because again, it's NFA. You convert to DFA, it is equivalent, of course. So when you try this, A B again, accepted, A rejected, B rejected, rejected. So on and so forth. So that's what. So in the visualization part, I would use that later in more complex, like something like this, so that you have more visualization, because A B is just two like a three state, like the state and final, like something like that. So it's no point. Like, I mean, the simple diagram lang. So we will use this later in a more complex way. So here I'm gonna go and choose 5 because I want to enter another one. Like for example, here test case. Oh wait, later I will screenshot this. So union operator. So A union B, something like that. So yes, there you go. This is how union works. This the summary of transition table, the DFA again, and there's an option for it. So here is the infix and the postfix, and I will test string again. So A or unit to B is just like saying A or B. So when I say A here, it's accepted, and B here is accepted. So somewhat like that, which means with B is accepted since the language accepts either A or B. So that's how you do it. So if you open put AB, it will not be, because this is in concatenation of the two. It's not or. So it should be A or B. That's the simple logic about that. So again, it's the same with the diff A. Let's say A, B, AB. Let's say it's still the same because it's equivalent. So next we'll try another test case. Clean star, so A star. So we'll test it on FA, A, accept that A, and all possible A's. Even the empty string is accepted because star itself, or the clean star, accepts 0 to a many. So that's that. So if you input B, it's not accepted. So let's go back. So that's in DFA, similar cases here, like A, it says A, wow, it's similar. So we will just test NFA and assume that DFA is just similar results with the NFA. So we'll make use of time because it's already 8 minutes. So here is we'll try. I guess we did try all the possible, including the rejection. So I think it's pointless. So here a complex expression. Let's go to the complex expressions. So let's go back, enter again, another expression. So let's say, let's copy this A or B, clean star, A, B, B. So let's type that. So far, this is the transition table, the diff A, and this is the NFA table summary. So let's test it. So in this case, in our input A, B, B, it should be accepted. So let's try. If wait, I know. I will test. I will test. Sorry, I got excited there. Oh, I didn't put. Actually, I didn't put F string. I mean next space here because invalid option, and then they say choose lang. So my bad there. It should be 1 to 6. I'm glad that I have a, what do you call this? Error handling. So again, I mean, I will test NFA, and I will test the AABB. So it should yield accepted. So yes, let's go. So this because if you say the expression A or B, so it could be either starting from A or B. So this the no, this the logic. So since the string belongs to the language of all A's and B's, ending in AABB, so it could it could be starting. Wait, where is it? Are. It could start in A or B and ends. The logic here, it could start A and B, or I mean A or B, anything anything inside that, or middle part of it, anything anything in it, and it should ends primarily ends in the pattern of A B B, because it's the concatenation of A B and B. So the most important part, it ends in A and A B B. So in our test case here, we started with A and ends with A B B. So that's how I get accepted. So when do we get rejected? In this part, we can reject in simpler terms like we input C because C is not part of the language itself. And other, we could say that A B B B B. So in this case, we should end in A B B. So let's try. It should be rejected. Nah. Oh my god. It is rejected because in this case we start in A, but we should end in A B B. So this the pattern that should ending. So that's why we got rejected. So this is all about. So in the test strings DFA, we assume that it's still the same because they're equivalent because we somewhat transform it or convert it. So this in this case, I will use the NFA visualizer and the DFA visualizer because to showcase you that kind of library. It's already 12 minutes. I guess I cannot explain the whole code itself. Let's see. So when I click here, it will automatically download to the same folder of my program itself. Download in PNG format. So here, uh, diagram save into like this name. So I will find that. Wait, where did I put it? I think here, Automata. This. Oh, okay. This is it. Oh wow. I think never mind this, guys. It's just this how the the visualizer graph kind of works. If you let the program do it aside, because the visualizer or the app itself is wait, where is it? It is in app, and the Python itself becomes it. I can use it as a library in your program, so it can be messy. But this how the NFA look like. This one should be here so that would much be cleaner. But it's automatic. That's how. That's the downside of it. So let's try the DFA for say here DFA. Wow. So I did just try it. So no harm in that. Even if it looks messy, I just tried the library. So it's not that's not my thing to worry because I just imported the library and use it. So again, this is how our program works from parser, like our regression expression parser, regex parser to regex to NFA and NFA to DFA. So this is how our project or our program works, and this is the complete overview of our project itself. So we have state class here so that we could I could easily keep track of an object and make an object and make an object of the state itself. In our case with our sir, we usually use Q, not S, because instead I use S symbol like here. S. I don't know why I use S, because S is state. I don't know why sir use Q, because state is S. Sorry. I could just here change this to Q, and all of this will just follow through, because this is the state, or this is the class that I just call to make another object of the state, somewhat like that. So this is the NFA class, where when I pass NFA, it contains all the states. It contains all the states, like kumbaga, it's like a data structure that contains all the states. Aside from this, there is also a format of that, and this the concatenation. Like for example, there is for example there is AB BBB. So this function works with this kind of thing. So so like for example, the user doesn't need to input the period, because there's a standard, or there's a add concatenation symbols nang related to solving that problem. So the red X, like for example, this red X transform to postfix that I've shown you. It removes all the unnecessary, like this, the parentheses, into format like AB dot, because to read this is this two concatenated ng A concatenation to B. So when I concatenate another one, like for example ABB, the format in that postfix format is AB dot B dot. Like for example, AB like A concatenation to B, and AB here concatenation to B. And to if you want to like somewhat do this, like many B's, so like for example this AB dot B dot B, and there's another dot here. So AB A concatenate to B, and AB concatenate to B, and ABB, or the whole here, concatenate to B. So that's how the prefix works. So let's see if that's the output. Where did I do it? None here. AB A concatenate to B, AB concatenate to B, and ABB concatenate to B. So that's how the postfix works, the algorithm there. So I mean it's not the postfix itself, but the add concatenation. I mean the add concatenation symbol. That's how the add concatenation symbol were. I mean the add concatenation symbol made it easier for the program. Like let's say a wait A B B B B, it will made like A B B B B. That's how the add concatenation symbols, and the postfix do this. Man, yeah. So the Thompson construction is just my simpler term. Like this is this the red X. So this the algorithm. This is the algorithm name, and the red X to NFA. That's this this how. So basically that. And here epsilon closure, like
I did this because I don't know, just might fun because then again, if you have a state here, it should be an empty string here and be empty string here. That's the one handles the epsilon part, and here is just part of the simulated itself, or simulate is used in the is somewhat traversing to the NFA itself. So we could use it in the table like here, so that it could easily uh oh wait, where did I use the simulate? Uh simulate here in the simulation part. So in the testing case where if it is accepted or not. So this is how our program works basically. I've consumed a lot of time, not 20 minutes. So I think I've already shown you. Oh wait, did I? Ah yes, I show you the visualizer. Here. So I think it's all good. So I will close now the program. Thank you guys. Quit. Wow. So thank you. Wow. Thank you sir. Ah, tapos kilala ko.